So I have this bench here, as I said, like when you set up bench, you will get this directory. So let's ignore all the folders for now. I just want to focus on this one file, Procfile. Okay. When you run bench start, it uses this Procfile to run the processes. So Procfile stands for process files. Process file. It defines all the processes that run when you do bench start. Okay. So let's open this up in VS Code and start dissecting it. So we have Redis Cache, Redis Queue, Web, SocketIO, Watch, Scheduler, Worker. Okay. First of all, Web, which is, so you will see it's the name of the service, right? Name of the process, and then what's the command that is used to start that, right? So when you do bench start, it will open up 1, 2, 3, 4, 5, 6, 7 processes. So let's do that. Bench start. You will see if you scroll up, Redis Queue, Redis Queue, Redis Cache, Watch, SocketIO, right? This is actually like color coded, so you can see. Then Web, and here it shows. So you can see what logs are coming from which service. So Web process started on 8,000. So this process, right? So if we ignore all of them, let's comment it out. Just have this one process which runs this command. So if you manually also run this command, it will start the web server. If I stop it, right? And if I copy and manually run this, it will start the web server. See? So bench start is doing nothing but running this all in bulk at one time. Okay. So bench serve is actually using Honcho, right? In production, we use G-Unicorn or Unicorn for serving your websites, right? This is a web server. So let's start drawing. Okay. This is where we'll need the drawing. So let's make a web server like this. Web server. This is your web server. You can change which port it runs on. By default, it's 8,000. That is why when we went into the website, we entered event.localhost port 8,000. This is the web process. It gets the request, it sends the response. Okay. Client, right? Which talks to the web server. Okay. Let's move it here. And this is the communication that happens. Request, then server sends a response. Okay. One process is clear that runs, which is the actual web server, which is what is showing you the UI and everything. It's sending the files and whatnot, right? Workzook is a web application library. So this is not a server. Unicorn is a server, right? In production that we use. But this is the thing that powers Frappe's web server. When you run bench serve, right? Code app slash Frappe. And then if we open up, so I opened up the Frappe repository. I will show you where this thing is happening. We go to app.py and this, okay, application, right? So if you see, we are importing Workzook stuff here, right? Because this is what powers Frappe's web server, okay? We aren't writing a web server from scratch. We are using Workzook. That was one of the pieces. Let's look at the next one, bench watch. So this is only for development. You won't run this on production. What bench watch does is it looks for changes in your Python file and reloads your server code. So you don't have to manually go and restart bench every time you change your Python code. In production, this is not running. So whenever you pull in your new Python changes from your GitHub or you make some changes in your Python file, you will have to manually restart. So web server loads in your new code. But in development, we are using this watch process, bench watch, to watch for file changes and reload your web server ka code automatically. So you don't have to. So there is this watch. This is only in development. Let's mark it orange. Okay, makes sense? So this is only in development and it watches for changes and then reloads your code. So this is clear. Where is the database here? No. So bench start doesn't start your database or anything because database server is separate thing, right? It's already running there. Bench or whenever you are creating a bench new site, it asks you for the credentials and then automatically went and created a database there. Okay. We'll get to that at the end of this. So it's already started. Bench assumes that your database server is there live up and running. So it can talk to it. That was database. So we'll draw it, but we'll cover it in depth later. So I'll draw it as a circle. So web server talks to your database server. Okay. For creating a new site database. So each site that you have has a separate database. I will show you after the Procfile. Okay. So this is the database server, which is what we will cover. Okay. Spending for now. So now we have covered two processes. Now here we have two Redis instances, right? Two Redis servers are being started. One is the cache, which is used for caching, right? When we were doing clear cache, when we were doing clear website cache, what is this cache, right? So we use Redis for caching, and this is the process that we use, and it is using the configuration store.config/rediscache.conf, which is, if you see, bench has a config folder. Let's go inside it. And if we do ls, you will see rediscache.conf. So let's open that up in VS Code. Rediscache.conf. And it has some policy, what port you should listen to, what's the maximum memory, right? What's the maximum RAM you can use, because cache is in RAM. What's the memory policy? What if, like, if memory is full, it will do LRU. The least recently used will be kept, older ones will be deleted. It's like, okay, if you use that key, it will keep it. Whatever was recently used, it will keep it. Okay. And there are some more that you don't have to worry about. Let's close it. So this is what the configuration file is. If you have to ever locally try some different Redis configuration, you edit this file and then restart your bench. Okay, so it will restart this Redis server for you. So let's draw this in this as well. So let's draw it as a diamond. Still keep it blue. We'll call it Redis Cache. So your web server uses it to cache stuff. Make sense? Now we have covered 1, 2, 3. 1, 2, and 3 processes right now. 1, 2, 3. So let's make client probably red or black. So this blue are the processes in the Procfile. The next one is Redis Cache. This is using a different config, right? It's still in the config folder. Still starting a Redis instance. So we have two Redis instances in Frappe. Earlier it used to be 3. That's for you to find out. Now it is just 2, right? Redis Queue. So this is used for queuing. So what happens is when you are serving website content, there are things that you might want to run in the background. So it is for that. And so queue is closely related to the worker, but we'll keep it on top for now. So let's make a Redis queue. This is also used by your web server for queuing, right? So to queue background jobs, etc. We'll come to SocketIO at the end, which is the most sophisticated setup. Bench schedule. So this is the scheduler. Scheduler. This is the thing that is responsible for handling your cron jobs. So when you tell Frappe, as we'll see later, that okay, run this script or this Python files, this function every month. Suppose you are finalizing your invoices every month. So scheduler is the process, gets your code run every month, right? Or every 5 minutes or every 10 minutes. You can give your cron expression as well. Okay, run every June, July on 3rd at 10 a.m. That level of granularity you can give in cron jobs, right? In cron syntax. So this is the process that will make sure that, okay, it will keep looking, okay, is it time? Is it time? Is it time? And it will say, okay, now it's time. Let's run this script. It won't run it. It will queue it. Okay. it will put it in the queue. So let's take this one and put it here. Make it nice, rounded like this. It will wait for the right time to run a script, and this will put this in your Redis queue, or we can call it BG jobs, background jobs. What will happen? Does it make sense now? So scheduler doesn't run your job. It will just wait for the right time and queue it at the right time. Running your jobs is someone else's job, right? Web server won't run your job, right? Your background jobs won't be run in web server. So who does this job, right? So there are workers. This is one worker, but you can create multiple workers like this just by calling it, let's worker 2. Then you can call it worker 3, right? So you can create copies of workers. These are separate processes that will do your work. Let's keep just one worker for now. There can be multiple workers, and it's running the bench worker command. It's logging your worker logs in worker.log in the logs directory, and your error, whatever happens in the background, right, it will log in worker.error.log. So we can check this logs folder. So let's do ls, go back, cd, logs, ls, worker.log. Let's check worker.log. Successfully completed this job, successfully completed that job, result is kept for this job. Okay, job. Okay. So it's keeping your logs. These are normal logs. And if you do worker.error.log, you will see whenever a job fails, it keeps the logs that, okay, aborted, fatal error, something, cannot do this, cannot import, this is deprecated, this is that. So you understand. So what happens is worker, right? Let's draw the worker as a circle here. There can be n number of workers, right? So I'm just drawing one worker for now. Picks up your jobs from your queue and run them. Will pick the job and run. Pick the job and run. Because Frappe has this out of the box batteries included feature of background jobs. It has all these processes that are there to manage it. So worker is nothing but a Python process that will spin up. It will have the context. It will pick up the jobs from the queue and then start running. Make sense? So what will happen? Suppose you write a script. You say, okay, finalize this invoices every month at 9 a.m. So whenever the end of the month comes at 9 a.m., scheduler will take the job, put it in a queue that as a job, right? It will take your script, put it in a queue as a job. Then your worker will pick it up and finalize the invoices and run that script. These are background jobs. That is why we have a separate Redis for caching and for queuing or background jobs. Fine. So now what remains is SocketIO. This one is tricky. So SocketIO is a separate protocol. It doesn't operate like this, right? It doesn't operate as a request response over HTTP. So this is HTTP protocol where the client has to make a request and then they will get a response, right? Okay, I want the home page. Server will respond with the home page. Here, server is not able to make a request to client. Server won't be able to make a request to the client and get response back. It's only one way. I will make a request. I will get a response from the server. But in case of real time, you were seeing I was not making any request to the backend. But still in the UI, it was showing, okay, you come joined or Putu joined or someone joined, right? Gaurav joined. How was it coming? How was server able to notify me? For that, we use SocketIO, which is a technology which enables this real-time communication between the client and the web server. So let's draw that process now. I will draw SocketIO here. This is a node process. So if we go back, see, uncomment, you will see it's a node process and a JavaScript file is being run. This is why, like Frappe, you have to set up Node.js as well before becoming bench. This is where it is used, the node. It's used at other place as well, but only one process in Procfile that uses Node, which is this SocketIO.js. I'll show you the code as well, don't worry. So this is the process that is responsible for SocketIO. But how is it communicating with, and who is it communicating with? What is SocketIO doing? Because ultimately the real-time events have to be sent to client, right? And this is the process that is responsible for sending those events and talking to the client via the SocketIO protocol. How do we talk? So what happens is, when your site is loaded, the client makes a request to your web server that, okay, I want to use real-time events. What do you want to do? I want to use real-time events. So what your web server will do is, in production, it will maybe Nginx that does this, right? It will upgrade this request, normal request, to a SocketIO connection to your SocketIO process. Because our web server can't talk SocketIO, it just talks HTTP, request response, normal stuff. But the SocketIO process, which is powered by a node, can speak SocketIO with the client. So there will be one request to the client. Let's make it like this, to upgrade to SocketIO. So it will upgrade the connection, let's say upgrade connection is fine. So those who are like have been working with Frappe also, let me know if this is something new you found out. We made a request to upgrade the connection, then web server will upgrade the connection, and then SocketIO will start handling your stuff. But SocketIO doesn't know about your Frappe site. Frappe site as in doesn't know about your data. It's not talking to database. How are the real-time events coming? So somehow the web server has to talk to SocketIO that, okay, something changed in the database. When you joined the channel, right, some Python code was executed. Here JavaScript is there, Node.js. How do a Python web server talk to a JavaScript SocketIO process? Because SocketIO real time, only SocketIO can talk to the client. Web server can talk Python request response. Here they have to work together, right? That, okay, whenever in web server I joined a channel, I want to notify the client about this real time thing. So I can't directly go to the client with a real time event. I have to go through SocketIO. So what will happen is, let's bring it here. We use this Redis queue to talk to SocketIO. Just bear with me, I'll explain. But web server will push the event, into queue. So we are using Redis queue for multiple purposes. One was background jobs. Now we are using it to talk to SocketIO. And then Redis will push this event to the SocketIO client, or let's say notify about the event. So what is happening? Via communication. So web server is pushing the event to Redis queue, and Redis queue is then notifying SocketIO that there is an event. Now SocketIO can go and talk to the client about the real-time event. So this is all what happened when you joined the channel. So when you joined the channel, some event triggered in web server, right? When you joined the Raven channel, web server then notified that event. We have special code that you can use in your app as well to publish this event. So you don't have to bother about this. You have a nice abstracted Python method for doing so. That will push this event in the queue in a particular namespace. And then SocketIO, who is a subscriber of this event, will be notified. And then SocketIO can deliver it to the client that, okay, Manik joined. This is how it works. Let's jump to the code and I'll show you. So let's go to this socketio.js file, which is inside apps frappe socketio.js. cd dot clear code app/frappe/socketio.js, which just has this realtime.js. And if you scroll down, it is creating a new SocketIO server. That is good, which is this thing, SocketIO server. Then will come down. Scroll down. See, consume events sent from Python via Redis pub sub channel, publish, subscribe. So this is kind of like YouTube. So you have a YouTube channel that you subscribe, and whenever the YouTuber uploads a new video, YouTube will notify you that a new video has been uploaded. So it publishes to you, and you have subscribed to this channel. So that is publish subscribe thing. So web server is publishing the event, not Redis queue. Redis queue is pushing the event to the subscriber, right? Who is publishing the event? The web server. Who publishes videos? YouTuber or YouTube? Think YouTube. Okay. You are the client, you subscribe. So here SocketIO is the client, it's subscribed. So whenever a new video comes, let me know. Click the notify button. Okay. Then YouTube is Redis queue. Who is publishing videos? The YouTuber. In this case, it is the web server. It will say, okay, Pudu joined this channel to Redis queue. It will publish that event. Okay, this happened. And then Redis will check who are my subscribers. In this case, there is the SocketIO server who is a subscriber, and then it will push those changes to the subscriber. So this is the pub sub pattern where there can be multiple subscribers as well, right? So web server is the YouTuber. It will push it to Redis queue as YouTube. And then this will push the event or notify that, okay, this event happened. This was the payload. You are a subscriber. Do what you want with it. So let's see. So it's subscribing to this events namespace and it gets a message. So this is get Redis subscriber. So it's talking to your Redis queue. So if I click here and you go inside, you will see it's talking to this Redis queue process. Exactly what we saw here, right? It's talking to the Redis queue process and it's becoming a subscriber. And it is saying whenever, so it's subscriber, it's subscribing to the events and it's giving a function. So whenever a new event comes in, analogous to a new video comes in, do this. So it will do this, get the message, parse it, because you can't push Python objects, right? What server side does is it will convert your Python object into a JSON string, then it will send to Redis. Then Redis will push that JSON string to your Node.js process, which is the SocketIO. That is why it is parsing that JSON to convert it into an actual object. And then it is using this real-time emit to notify it to the client. Notify to client, which is this communication happening. We covered a lot, but this is from subscriber side. Let's see from the publisher side. So for publisher side, we'll have to open up Frappe app. And there is a function called publish real time, which you as a developer can also call. And we'll see what it does is it's on the web server side. Let's scroll down. Emit via Redis. Let's click this. And it's getting the Redis connection and publishing it. So this is the publisher. Channel name is exactly the same. If you see the JS side, I'll show you. If you see the JS side, events. If you see the Python side, events. Here it is dumping it to JSON. Here it is parsing it from JSON. Make sense? So this is how Python process and JavaScript process are communicating via Redis. It's a nice design if you see. You just have to do frappe.publish real time in your custom app. Publish real time. You give it a name of the event, right? You will say, okay, channel join, right? I'll show you an example. And then you some metadata that user who joined the channel, right? abc.com, abc@email.com. This you write in your Python custom app. Then all the magic will happen that we saw. There is not magic now. Now you understand that it will go and put it in Redis, and then whoever is the subscriber SocketIO will push, and whoever is the client, right? Whoever is the client who wants this event, For example, I was in the channel, so I was one of the clients who was listening for this events in the browser. There you have to write your JavaScript code, frappe.realtime.on, give it the same channel name, and do whatever you want with the data that comes back. In that case, this will be the user. So you write this in your Python side, and you write this in your JavaScript side. You don't have to worry about Redis or anything. You just work with these two abstractions as a developer. But now you know if something goes wrong, how it is working, what might be wrong, etc., etc. Yeah, it covers.
What will happen when we run the command bench setup production?
No, it will
Actually, it reads the
do some
Procfile
stuff.
and do the configs.
No, so in production, right, a different process manager is used, which is called supervisor.
Okay.
So supervisor will then manage your processes.
So how the processes are created? It uses the same Procfile, or it uses that config file, site config file.
But let's see. I haven't set up production. I just set it up once. I've been using Frappe Cloud since then, but we'll Procfile Frappe production. We'll find out. Honcho to manage. This is developer mode. Okay. Optionally, if you're developing benchmark, that is fine. We know. Redis Cache, Redis Queue, this, that is fine. It's broken. Frappe setup production. Let's read that. Easy production setup. The configuration will be where you can copy this supervisor config directly and reload it to. Okay. Bench setup supervisor. I told you, right? We use supervisor. And then it generates your configuration supervisor config. I'm just checking. So how can we find out, right, what is happening when you do bench setup supervisor? So bench is also open source. Let's do this. So I want to see if Procfile has any use in production. My hypothesis, no, because it might be generating the config on the fly as we saw right now, right? So bench commands setup production. Setup production. Yep. Setup production. Then it calls this. Where is it importing it from? Config.production setup. Okay. Config production setup. Setup production. Setting up prerequisites. Bench path.conf. Restart supervisor on update. Oh, it's using the common side config. It's using the common side config. That is why this common side config. Where is it? If we open it up again, code. Yeah, if we do two here, I think, and then set up production, it will then generate two, what do you say, two workers for it, two worker processes for it. Because this is the conf, right? See, it's reading this restart Nginx on update, restart this, that from there. Cool. So this is clear now. So what is happening is Procfile is used by bench start, which is Honcho, to run those processes in development. But in production, supervisor is run. But the thing remains same, right? Still, you will load Redis Cache, Redis Queue, SocketIO, etc. And then if you see it's setting up Nginx, creating your configuration for Nginx, some stuff other, etc., etc. Cool. Even I learned a new thing. That's good.